In this video, we are going to look at the concept of electrolysis of aqueous solutions for chemistry. Now, after going through this video, I guarantee you that you understand the electrolysis of aqueous solutions for chemistry. Alright, now I want you to pay attention very well in this video, because this electrolysis of aqueous solutions is one topic that oftentimes confuses students. I'm going to simplify the concepts behind it, so ensure you stay to the very end of this video. Okay, so having known this, let's go into the details of the video. We are looking at electrolysis of aqueous solutions. Now, let's begin by noting this. In aqueous solutions, as well as the ions from the ionic compound, there will be hydrogen ions and hydroxide ions from the water. Since we are dealing with an aqueous solution, I know that the solution has to deal with water and a solute. In the water or the solvent, this is how hydrogen ion and hydroxide ion are produced. So we're going to have hydrogen ion plus hydroxide ion. So this is basically what we are going to have. Now, note that this reaction is a reversible reaction. Okay, so take note of this. Now, the second thing you have to take note of in electrolysis of aqueous solutions, at the cathode, if hydrogen ions and metal ions are present, hydrogen gas will be produced. If the metal ions form an elemental metal that is more reactive than hydrogen. Okay, now this is very important. Now let's list the reactive series of metals again. So we have it to be potassium, sodium, we have lithium, we have calcium, we have magnesium, okay, we have carbon, we have zinc, we have iron, we have hydrogen, and we have copper. So basically, in this reactivity series of metals, at the cathode, the hydrogen gas will be produced if the metal ions form an elemental metal that is more reactive than hydrogen. For instance, let's say in this electrolysis of sodium chloride, okay, we have sodium chloride. Now, in this sodium chloride, the sodium will not migrate to the cathode, because in this electrolysis of sodium chloride, we have this following different ions. We have our sodium ion, we have our chloride ion, we have our hydrogen ion, and we have our hydroxide ion. Alright, so we have two metal ions here, and sodium is more reactive than hydrogen ion. Okay, so sodium will not migrate to the cathode to get reduced. Rather, hydrogen ion, this time around, will migrate to the cathode to produce hydrogen gas. So when it is reduced, it produces hydrogen gas, and this will be the reduction equation for it. It's going to be, so it's going to gain 2 electrons to form hydrogen gas. Okay, so in an electrolysis of an ionic compound, if the metal involved in the solution is more reactive than the hydrogen will migrate to the cathode to get reduced in order to produce hydrogen gas. Okay, now the other way around, if the metal involved is less reactive than the hydrogen ion, the metal will this time around migrate to the cathode to get reduced to the neutral form of it, or to form the atom of the metal. For instance, in this electrolysis of copper sulfate, in copper sulfate, copper is less reactive than hydrogen. In this reactivity series of metals we have here, so copper is less reactive than hydrogen. So to show the reduction equation for this is going to be copper ion we gain 2 electrons to form copper atom. Okay, so that's basically what you are going to have. Now, the next thing you have to note again is that at the anode, if hydroxide and halide ions, halides, they're talking about halogens. But when we say halide, we're talking about halogens, and halogens are elements in group 7 of the periodic table. They include fluorine, chlorine, bromine, iodine. So at the anode, if hydroxide and halide ions are present, molecules of chlorine, bromine, or iodine will be formed. Okay, if no halide ions are present, then the hydroxide ions are discharged and oxygen will be formed together with water. Okay, let me show you. For instance, let me wipe up. Okay, now in the electrolysis of aqueous solutions involving sodium chloride, chloride ions are present in the solution. So at the anode, chlorine gas will be produced, and this will be the oxidation equation, half equation for it. So it's going to be chloride ion will lose 2 electrons to form chlorine gas. So balance the equation. Okay, so this is what you're going to have. Whereas in the electrolysis of aqueous solutions involving copper sulfate, so in this solution, halide ions are not present, which include chlorine, bromine, iodine, etc. So basically what will happen here is that the hydroxide ions will be discharged at the anode to produce oxygen gas and water. Okay, so this will be the oxidation half equation for the reaction. So we're going to have it to be hydroxide ion. It will lose 4 electrons to form oxygen gas, oxygen molecule, and water molecule. Alright, so to balance this equation, we are going to add 2 here. So this equation is now balanced. Okay, very, very important, guys. Now, before we call it a class, let me show you how you can combine 2 half equations in case you're asked in your chemistry. So let's wipe some parts of this. So for the combined half equations for the aqueous solution, electrolysis of aqueous solutions involving sodium chloride, here is going to be, remember, in sodium chloride, the sodium didn't get discharged at the cathode because sodium was more reactive than hydrogen in the reactivity series of metals. So the hydrogen got discharged at the cathode to form hydrogen gas. So that's why we have the reaction on the cathode to be this. They have equation on the cathode to be this. So if you're combining it with the negative ion in the compound, which is the chloride ion, so this is the half equation for the chloride ion at the anode to form chlorine gas and molecule. So if you want to combine these half equations, it's going to be hydrogen ion plus chloride ion to give hydrogen gas and chlorine gas. Okay, so this will be the combined equation for the half equations involving sodium chloride. So let's go to the class here, guys. Hope you learned something interesting from this video. The main thing here is that you just have to practice often. So get used to writing these half equations and the combined equations of electrolysis of aqueous solutions. Hope you learned something interesting from the video. Now, if you are new to the channel, ensure you check the description of this video below. Same link to our Telegram channel. Click on it and join the Telegram channel for instant notification. Also ensure that you subscribe to this channel by hitting the subscribe button. More videos like this. Like, share, and comment on this video. Tell me how you feel from what I learned from this class. If you seem to have any specific questions asked regarding this topic for minutes to, feel free to do this in the comment section below. And I will be sure to give a response. Now click on the end screen above and I will see you in the next video. Thanks for watching.